My name is Allan Poulsen. I'm heading the Advanced Structures and Sustainability in Vestas. That is the part of the Innovation and Concepts department. The CTEC project, it's a consortia consisting of 4 partners. So that is Vestas, it's Olin Epoxy, it's Aarhus University, and then it is the Danish Teknologisk Institut. In the CTEC project, we try to scale up epoxy resin technology that we have developed in a previous project called DreamWind. So if we start from DreamWind, in the DreamWind project that has started, let's say 4 years ago or so from now, it was also a 3-year project. We developed a resin that could be dismantled at end of life, so we could take it from each other. That resin that we made the proof of concept for in the DreamWind project after 3 years is the resin we're going to work on in the CTEC project. But now the focus is on making it up into an industrial scale. So that is to being able to make an industrial synthesis of the basic compounds for the epoxy resin. And then it is to commercialize it. So that is to bring it that far so that we know how to deeply trust in the technology, and then also develop the area around recycling of this epoxy resin, and then scale it up and make it commercially viable, because it is necessary to make it commercially both available and viable in order to be a success. It's not only a resin that Vestas is going to use for blades, it's a resin that's going to be available for anyone who is working on epoxy resins, because that will drive down the cost and increase the volumes. Also, when it comes to recycling, when that time comes, then it will also be attractive to recycle and build a business around recycling of the epoxy. To develop materials, that's actually a very long stretch when you do that. There's a lot of challenges that you face here. So one thing is that you're in the lab, develop a material, and you can determine the properties of it, what it's capable of doing with regards to durability and that kind of stuff. But that's one thing. Then to scale it up into an industrial process, that's another story, because then you need to figure out how do you make the synthesis of the cheapest chemicals in the most favorable way, and so on. So that is a challenge. That is the upscaling. And then, of course, then there's also the challenge around that to secure that you have the value stream around these chemicals. So you have these companies who can supply the basic chemicals. And when you have all that, then the next step is to make it commercially viable. And that is to make all the tests so people, they really believe in this epoxy. So now you have a epoxy that's synthesized, you have a resin that can be, epoxy that can be made from the chemicals. You can make it commercially available and make a business around it. And then the final step, that is to degrade it again back to the basic components. That's also a part of the CTEC project. That is to develop this catalyzed reaction or process that makes it that transform it back to the basic chemicals. And we have a proof of concept here where we've proven that it's a very efficient process that we've developed, but we are going to improve that process even further and also develop the process, so to say, so we move from the laboratory out into the real life with some pilot tests. There's still a lot of challenges, both from chemical side, from the recycling side, and then especially also from the commercial side. In Vestas, we have made the LCA, that is life cycle analysis of our product, and we have made that down to each single component that is in the wind turbine. So we have a really good overview of what is recyclable and not, and the impact on the environment from all our products. It's true that most of the wind turbine is recyclable, and actually when we're looking down to the blades and making these recyclable, then we have very few percentages left that is difficult to recycle. But it's still, a smaller challenge to either substitute or make these materials recyclable, especially in the future, than the blades. That is the biggest parts right now to recycle. We are targeting that part of the wind turbine that is hardest to recycle right now, and where we also have the most materials that is non-recyclable on the wind turbine. So the remaining parts, we will figure out a way to recycle this part as well. Our ambition with this technology is that we are designing a material that is actually designed for disassembly. It's not the component that is designed for disassembly, it is the material. So we are looking at the basic components. How do we design these to a circular economy? It's also important to emphasize, at least from our side, that we don't expect that the properties of these materials are going to decrease. We're actually expecting them to be on par with the existing materials. Our ambitions are that this resin can actually substitute the existing epoxy resin, and it's not going to change anything about durability, about the physical or chemical properties. That's the ambition we have. The big issue today is that the blades that we recycle, the material we get after recycling, cannot be used in a blade, in a new blade. It cannot be used for other components where we expect a high degree of durability or strength. So it's heavily downcycled. And that is actually what we address here. That is that we would like to make a resin that can actually be truly a part of a circular economy, and we can get the same properties we expect of existing materials that we already use. And also with regards to the properties in the factory, so that we are not going to change our design or increase the mass of the blade or factory footprint and so on. It will still be the same as with the existing epoxy. We expect blades to have durability of 25 to 30 years. That's a lifetime. That's the expected lifetime for a blade. And it will take some time before that goes back and it's going to be recycled. So that's not the first component made from this resin that we expect is going to be recycled. We will also look into other industries that are going to use epoxy resins, which are getting back into the recycling loop much faster. That could, for instance, be the automotive industry, where the life expectancy of some of the components is much shorter. That's only one industry, but there's a lot of industry using epoxy resins. And our ambition is to tap into all the industries using epoxy resins so that we can get some scale on this. Again, making it attractive to recycle and make it attractive to use. That is really important for this technology to make it a success. I think other industries, they should also start to take this seriously and try to design circularity into the materials. Even though that we say that thermoplastics, they are recyclable, they are to some extent, but they're not truly recyclable. They're also downcycled each time. So somehow we need to think, how can the basic components in the materials enter into a circular economy? That will take a long time before we have designed new materials, because it's both expensive and time consuming. And then again, the companies and also the consumers, they need to build up trust in these materials. I think it's great to see that the wind industry dare to take that step. And I really hope that a lot of other industries, they would go down the same path in the future. And we introduced a sustainability strategy in the beginning of 2020. And here are some of the key targets. That is that we are going to reduce our CO2 emissions in our own operations by 100% in 2030. And it's important to emphasize that that is without using carbon offsets. And another hot target here that we're working for, that is that we want to reduce, our ambition is to reduce our CO2 emissions in the supply chain by 45% per megawatt hour generated by 2030. And that is actually, one thing is that we address our own scope 1 and 2 emissions without using carbon offsets. But the really ambitious targets, that is also that we're going to address the CO2 emissions in our supply chain. And we are actually also very active on that part. In Vestas, we have had our carbon footprint and CO2 reduction science-based target approved. So that is on the carbon footprint. On the circularity part, we are still working on developing that. And we have some hard targets on the hub and blade to be 55% recyclable by 2030. But the hard target is that we want to produce zero waste wind turbines by 2040. We're already working dedicated on reducing both the waste generated from our production of components, but definitely also the waste that we do generate, that is recycled to a higher degree, and also we are working hard to move away from landfilling of the waste that we generate. So we have a lot of activities here, and we're also setting targets for our supply chain, both on CO2 emission, but definitely also on the zero waste wind turbines. And here we have strategic suppliers that have hard targets on CO2 and the waste part, and that is besides reporting these numbers to Vestas, of course, so we can follow how they reduce the CO2 emission and waste. So we are very ambitious and have set targets not only to ourselves but also to our supply chain on sustainability. To us, it's very important to be a member of the Renewable UK in order to have an organization or a place where these companies who is working towards a more sustainable future can work together on development of technologies and processes and products that actually supports this journey for a more sustainable future. So to tie these activities together so that we can actually get faster towards a reduced carbon emission, for instance, and that's important for us.